Hello everybody, welcome to another video lesson. Today we're looking at geometric series and we're going to be able to find the sum of geometric series, and we're going to learn a new thing called sigma notation. And we're going to learn how to utilize sigma notation by the end of this video. Okay, so let's hop into it. First things first, what is a geometric series? Well, that's just when we take a look at the sum of the terms in a geometric sequence. Okay, and we have a couple of formulas for finding the partial sum of a geometric series, and it depends on what we're given. So each time we need to know the first term, okay, and then we either need to know the nth term or the number of terms that we're adding up. Okay, so this here would be the number of terms that we're adding up, and this one would be the nth term. Okay, so we have two separate formulas for that. Okay, so the sum S sub n, that's how we denote the sum S sub n, okay, of the first n terms. We're going to use these two formulas here. Okay, so I've got a sub 1 minus a sub 1 times r to the n. Again, r to the n, r is the only thing being raised to the nth power, okay, not this a sub 1. Okay, it's just r raised to the nth power, then being multiplied by a sub 1. All right, and then here I've got a sub 1 minus a sub n times r, and both of these are going to be over 1 minus r, where r cannot equal 1, okay, because that would give us a 0 in our denominator, which is no bueno. Okay, so let's go over this new thing called sigma notation now, okay? Now you might see something that looks like this, and you're like, what is going on? What does this mean? Well, this is, okay, our term for sigma, which S sigma is for sum. Okay, so we're looking at the sum of a bunch of different terms. And I put this f of k in here because this is kind of similar to what we might think of as like function notation. Okay, now keep in mind I have a term here on the bottom, or a number here on the bottom, and a number here on the top. These have to be integers. Okay, we're counting up by integers. And the one on the bottom here is going to be our starting term, okay? And these are kind of what we call dummy variables, because they're not really variables, but they are kind of number placeholders as I move along each term of my geometric series, okay? And then the number on top, that's going to be my final term, my end term, okay? So let's have a little example here on the side, okay? I've got the sum from k equals 1 to 4 of k squared. Okay, so all we're doing here is I'm going to say, okay, what is this term when k equals 1? When k equals 1, I've got 1 squared. Now, since this is the sum, okay, I'm going to add that to the term when k is equal to 2. Then I'm going to add that to the term when k is equal to 3, and then when k is equal to 4. Okay, so all I'm doing is I'm plugging in 1 here for the first one, and then I'm going up to 2. So k is equal to 2, and then I plug that in, and then I go up to 3, and then up to 4, and I'm adding all these terms together. Okay, so I go ahead and I just add them. So I've got 1 plus 4 plus 9 plus 16, and that equals 30. Okay, so this summation here is equal to 30. Okay, so that's our main concept for today. Let's take a look at a few examples. Okay, we're asked to find the sum of each geometric series, and we have 2 examples on this one. Okay, and we're given different information in each example. Okay, so we're going to be using our different formulas depending on what information we're given. Okay, so for this one, I'm going to use a sub 1 minus a sub 1 times r to the n over 1 minus r. Okay, because I'm given n is equal to 10, and on this one, I'm given a sub n. So I'm given n is equal to 10, I have to use that information that I'm given accordingly. Okay, so all I need to do is plug in a sub 1 here. A sub 1 is 2. So I have 2 minus 2 times 3 raised to the 10th power. So I know r is equal to 3, and n is equal to 10, so I'm just plugging in what I have. Okay, and then on my denominator, I've got 1 minus 3. So I'm going to start plugging those in. I have 2 minus 2 times 3 to the 10th power is 59,049. Okay, so then I can go ahead and start simplifying. So 2 times 59,049 is going to be 118,098. Okay, so 2 minus that is going to give me a negative 118,096 in my numerator. and then I have a negative 2 from this 1 minus 3 in my denominator. Okay, so when I go ahead and simplify that fraction, I get that the sum of the terms from the first term to the 10th term is going to be 59,048. Okay, so that's what that sum would be of that geometric series. Okay, in our second one, I'm given a sub n is 125. So we need to use our other formula here that says a sub 1 minus a sub n times r, all over 1 minus r again. Okay, so I know that a sub 1 is 2,000, minus a sub n is 125, and I am given r is equal to 1 half, sorry. Okay, so 125 times 1 half, and then again, I've got 1 minus r, which is 1 minus 1 half in my denominator. Okay, so I can start simplifying, so I get 1,937.5 divided by 1 half, and the sum of this geometric series is going to be 3,875. Okay, example number 2. Now we're looking at sigma notation, right? Okay, so we're asked to find the sum again, but now we have this sigma notation. So think about what we're asking for here. We're asked to find the sum from the 4th term, okay, because k starts at 4, that's my starting spot, to the 12th term, that's my ending term, right? So 4th to the 12th term, that's kind of the context of what we have here. Okay, so first thing I need to do is go ahead and evaluate this whole expression when k is equal to 4. Okay, so when k is equal to 4, I've got 1/4 times 3 raised to the 4 minus 1. So that's going to be 1/4 times 3 raised to the 3rd. That's going to be 6.75. And then I go one step further and I say when k is equal to 5, now I have 1/4, 3 to the 5 minus 1. So 1/4 times 3 to the 4th. Again, it's only the 3 that's being raised to the power here. So 3 to the 4th and then divided by 4 really is going to be 20.25. And then you just keep going. We're not going to do all of them together, but I do have them all written out. Okay, so when k is 6, 7, 8, 9, 10, 11, and finally 12, because that's our end spot here. Okay, so now I have all these terms, so we just need to add them all together. Okay, since this is the sum, right? Sigma notation tells us it's the sum that we're looking for. Okay, we're going to add all of these together. So you can just add all of them together in your calculator and you will find that we have a sum of 66,426.75. Okay, last example here. We're going to find the first term of a series. Okay, so we're finding a sub 1, that's our first term, in a geometric series for which we have the given information. Okay, the sum, s sub n, is equal to negative 26,240 when n is equal to 8 and r is equal to negative 3. So we're going to go ahead and use one of our formulas here. So I've got s sub n, that's our sum, is equal to a sub 1 minus a sub 1 times r raised to the n, all over 1 minus r. So I can just go ahead and plug in what I know. Okay, I know what the sum is. I just don't know what a sub 1 is, right? So I plug in what I have for r, and then I know that n is equal to 8. Okay, so I just plug in what I know again, and then I can start to solve for a sub 1. So what I did here, I just factored an a sub 1 out of my numerator, and that left me with a sub 1 times the quantity 1 minus negative 3 to the 8th power. Now be careful when you put this in your calculator. You're going to want to put it in just like this with the parentheses around the negative 3 and then raise the whole thing to the 8th power. Okay, because if you don't put these parentheses in here, it's going to basically say negative 1 times 3 to the 8th power. And it's going to give you a negative number, okay, when really this should be a positive number. Okay, so I can start solving for a sub 1 by multiplying both sides of my equation by 4. All right, so that's going to give me negative 104,960. That's equal to what I have left over here in my numerator, which is a sub 1 times 1 minus negative 3 to the 8th is 6,561. Okay, so that's going to give me, on the right-hand side, a sub 1 times negative 6,560. And I can divide that through both sides, and I get an a of 16. Okay, so that's how we can find the initial value, or the first term of a geometric series, using one of our formulas and the information that we are given. All right, you guys, that's all for this video lesson. Good luck with your practice.